the end of the previous part of this video lecture, I asked you to come up with the direction of the field at this point marked by X, near a water molecule. And what you need to do is a vector addition. Before I go on, I'll just say that one of the options can't possibly be right. As always, there is no such direction as positive, so that can't possibly be right. And I just put that there to remind you that that's still true. So the way to do it is to draw the individual vectors of the E fields due to each individual atom and add them. So to make that a little simpler to explain, I'm going to number those two hydrogen atoms, and then the fields look like this. The fields due to the hydrogen atoms point away from the hydrogen atoms, and the field due to the oxygen points towards the oxygen atom because it's negative. Those two fields due to the hydrogen atom are in opposite directions and are the same size, so they're going to cancel to give 0, and all we're going to be left with is the field due to the oxygen atom, which points up.
Another way of drawing and of thinking about fields is with field lines. Field line diagrams are different from field vector diagrams. In a vector diagram, we're drawing vectors at many different points, but in field line diagrams, we're drawing continuous lines or curves. The field is tangent to these lines everywhere. This is a different way of drawing and a different way of thinking about the field, and it's going to be particularly useful to us in the unit on Gauss's law, but for now we're just learning to draw them. So let's think about these two source charges, Q and negative Q, and we're going to use a probe charge to draw a field line. So let's start the probe charge near the positive charge Q, and we think about the total electrical force on it. We now move it a small distance in the direction of that force. And by small distance, I mean small in the calculus sense of small. We're letting these distances go to 0 so that we get nice, smooth lines. But I can't show moving it the millions and millions of tiny steps to get it to here. And so you'll just have to fill in that detail for yourself. In any case, I continue moving it in the direction of the electric force, tracing out a line as I go. In the end, I have to add a little arrowhead onto the line so that it indicates the direction that the line is pointing, so that someone looking at this knows that the field, which is tangent to the line everywhere, would, for example, at this point this way, not back this way. Every line starts on a positive charge and ends on a negative charge. To draw a full field line diagram, you need to draw multiple lines. And so you draw a number of lines attached to each charge that is proportional to the amount of charge on that charge.
Knowing how to draw and how to interpret field lines is going to be important as we go on, because I'm going to constantly be drawing pictures of field lines as I explain things. So here are several diagrams showing a pair of positive charges and some possibilities for one of the field lines which might result from them. But only one of these field lines is possibly correct. So which one is the one that could be correct?